Hello and welcome back to A Software Engineer Plays, the channel where a software engineer, that's me, plays through games designed to teach you how to program and think logically. In Human Resource Machine again today, let's go ahead and jump right in. Last time we looked at zero terminated sum, where we were adding up every number until we hit a zero, and we turned on both optimization lights for that problem. But let's go ahead and jump into room 23 here, the littlest number, and see what we can come up with. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. Alright, for each zero terminated string in the inbox, send only the smallest to the outbox. Okay. So I kind of want to copy, I think I want to copy from the last program, just because that will give us a good jumping off point, I think. Okay. Paste. Beautiful. Okay. So, we don't have to worry about zero strings here, so we don't need any of this additional code in here. But instead of adding to the result, we need to do extra logic in here to determine if it's smaller. And we only want to keep the smallest number. So, basically, we will get one number and store it in the result. And then we will pick up another number. So actually, I think I do want that additional code up there. Okay, so instead of adding the result, we want to subtract the result. Okay, so for the example of the first two numbers here, we get 6, now we get 13, we're going to subtract result. Now it's not negative, which means that the number was bigger, so if it's negative, we want to add back the results, and then copy to the results, and then jump back to the next inbox stage. Okay. So, we'll step through this here. So we have 7, right? And now we pick up 13. Now 13 minus 7 is 6, so that's not negative, so that means that 13 was bigger than the 7. So we're going to pick up the next number, and it's a 2. So now when we do our subtraction, we're going to get a negative 5, which is negative, which means that the number we had was smaller than 7, right? 2 was smaller than 7. So now we're going to add back our result to get that 2, and we're going to copy it to the result, and then jump. And now we're going to pick up a 0. And because that is a 0, we're going to pick up our result and ship it. Alright, so that seems to work. So now we're going to go ahead and start again. And I don't think we need this jump if 0, so if we're over by 1 on the size requirements, then we will take that out. But let's see how we do here. Alright, so it looks like our program's working. How do we do on size? We were over by 1, so as I suspected, we didn't actually need that that jump if 0, or jump if, yeah. So if I take this out, we should actually pass both, because that's an additional command that's getting executed every time through the loops. So let's just double check there. Alrighty. We did it in 13 commands with a speed of 73. Alright, very cool. So that was pretty quick because we were able to build on what we did in zero terminated sum, which is a really important thing in in computer science and programming, really, if you're able to write a generalized solution that you can reuse, it makes life so much easier down the road because you don't have to reinvent the wheel every time you need to come up with a new solution. So let's go ahead and jump into cumulative countdown here and see what we've got. What is the purpose of this assignment? I think it's something about calculating the volume beneath staircases. We have to put the intern somewhere. Okay. For each thing in the inbox, outbox, the sum of itself plus all numbers down to 0. For example, if the inbox is 3, outbox should be 6 because 3 plus 2 plus 1. Okay. So, we have to we're going to keep a result here. So basically we need to store this number in the result, and then I think I'm going to just declare a temp here. So we want to store inbox, copy to result, and then subtract. I think subtracting from the result isn't going to, or bumping down the result isn't going to work. I think we want to copy it to temp as well, and then bump down temp, add result, and store, and then do that until temp is 0, at which point we can jump out. And copy from the result and send to the outbox. So basically we need to, because of the way I think the handling the numbers works here, we have to have a copy of the number, 2 copies basically, because when we do a bump down, it doesn't just take up the number in your hands and do the math in your hands. It takes the number, bumps it down in the slot, and then picks up that number. So if we put a 3 here, and then did a bump down on it, we'd have a 2 and have no recollection of the 3, no memory of it anywhere. So I think this is what we have to do. So let's just see how that works. Okay, that's good so far. We get our 6. Now that's going to be a 0, so we're going to pick up the result and outbox it. Okay, so far so good. Do it again here. It's a 0, so we pick up the 1 and outbox it. Good. This is just going to be a 0, so this is going to be interesting. We didn't think about this. And that's going to loop forever now. If I put this in here, I think there's an achievement you can get for having numbers that are too big for the system, so I'm just going to let them run for a while. Just to prove to you that, yes, it is in fact looping infinitely. Alright, I don't have time for that. It's fun to watch, though. So I think what we're going to do is, if it's 0, right up here, we're just going to go straight to the outbox. Which will save us a lot of time. Alright, but how did we do in terms of speed and size? Size, right on, and speed, right on. Well, cool. Just as a side note, we could probably speed things up a little bit by having the outbox at the top of the program, and then having a jump straight into the inbox, because then it doesn't have to jump after the outbox, it's running straight into the program. Except in the cases where there is a 0, where this jump is now jumping to the wrong place. There we go. Let's see if this does speed it up at all. Previous our best was 82, I think, so now we should get a little bit of a speed increase there. But did we? No! Alright, well that's interesting. But, you know, we still turned on both lights earlier, so let's go ahead and take our coffee break and call it a day. Coffee. big mysterious orb rising from the clouds. Is it the moon? Oh, no, it's not the moon. It's an eye of some kind. It's a robot. I'm sure that's fine. Oh, and they're everywhere. Excellent. Well, if that doesn't get you pumped to solve more puzzles, I don't know what does. Alrighty, well, look at that. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 more levels to go, so hopefully another 12 to 15 videos, maybe more, depending on how difficult these get. And we'll be able to say goodbye to Human Resource Machine. But I'm going to say goodbye to you now. This has been A Software Engineer Plays. Thank you very much for watching. If you enjoyed the content, please consider liking and subscribing and sharing the channel with a friend. I hope you have a wonderful day. Bye.